Question 3 is asking, can interfaces be instantiated? Yes or no? Give a reason for your answer, and that is 2 marks. So, interfaces cannot be instantiated. Why? Because they are not classes. I'm not certain of the reason. So let's first confirm if indeed we cannot instantiate interfaces. Well, my experience says we cannot. Sorry, I just don't know why. So let's create an interface called A. Choose interface here. So we have that interface. Sorry. So instantiate this. Oh, yes, yes. So the answer is we cannot instantiate interfaces because uh, mm, because because what? Uh, mhm. So let's first create a class here. Class called B, and we're going to create a main method in the class. Get our interface A. Call it A is equal to new interface like that. Oh, no, like that. So we cannot create the interface as we can see here. Oh, thank you. So we cannot create, we cannot instantiate an interface because interfaces are abstract. Yeah, I had forgotten. So basically, an interface, this interface here is like saying, remove the word interface and put abstract class like that. So basically that is what an interface is. It's an abstract class. So meaning we cannot instantiate abstract classes, or we cannot instantiate an interface because let's put the reason here. So can interfaces be instantiated? No. Reason: interfaces are incomplete and abstract classes. So that's the reason. So internally, an interface is a class. It's an incomplete and abstract class internally in Java. So that's why we cannot instantiate it, and the reason is it's an incomplete and abstract class because inside an interface you can have stuff like public, static, final, int. You can have constants like this, and give it a name, public, static, final. You can have constants like that, and you can also have abstract methods. So abstract methods like public, void, public, abstract, void, it. So remember, once you have an abstract method hmm, inside the class, then that class becomes what? Public. Ah. Then the class becomes an abstract class, unless you of course implement the you give this a body and you implement it as a concrete what method. But you can also have what you can also have complete classes. For example, let's have a public default returns void, returns nothing, run, like this. So when it's a default method, you must provide a what? A body like that. Because when you don't, it complains. It says default classes must have a what? Must have a body. Because default classes must be complete. So you can have that. You can have this in an interface, and you can also have a what? An abstract method. You can also have another one called a static method, public static void, and this is work like this. And this must also be implemented. They must also have a body like this. So these are the kinds of stuff you can have in an interface. But an interface is abstract. It's an abstract class. That's why you cannot instantiate it like this using the new keyword and these brackets. So the reason is you cannot instantiate an interface and you cannot instantiate an interface, and the reason is interfaces are incomplete and abstract classes. Okay. So using an example of your choice, demonstrate the concept of multiple inheritance in interfaces. Multiple inheritance in interfaces. Okay. So let's create some other interface called C. Oh, put the class. Okay. Public interface called C. You can see the icon changes from C if it's a class like this, from C in blue to I with a green green foreground. So that's an interface, and they want us to demonstrate the concept of multiple inheritance using interfaces. So let's create some other interfaces down here. We're going to have interface D. We shall have interface E. That's enough. Let's put one more interface. B, C, D, E, F, like that. So to demonstrate multiple inheritance using an interface, when it's a class, we use the what? The keyword extends. But that also applies when it's a what? When it's an interface, because an interface cannot implement other interfaces like this. Cannot do this. You cannot implement an interface like this and then another one like this. Wait, why is this working? Then another one like this. Okay, it's not working. So you cannot do this. You cannot implement multiple interfaces like this, like how we did. Like if you would have done if this was a what? A class, like this. If it's a class, then you can implement the interfaces like this with commas. But if it's an interface that you want to extend to use multiple inheritance on, then you have to use the keyword extends like this instead of what? Instead of implementing. because an interface cannot implement another what interface, because that would mean whichever abstract methods are inside here, you must then what implement them inside this what inside this body, which is not possible within an interface, because you cannot have um, implemented you cannot have overridden methods inside the what inside the body of an interface. So you cannot implement them, you can only extend. So by extending these other interfaces, you are taking on the abstract methods inside these other interfaces. These other interfaces will have abstract methods inside them, like that. And by extending these other interfaces, these ones, you are also taking on those same abstract methods and maybe any other constants. Any other constants inside these interfaces. So then what will happen when you have a class that implements a class Z that implements this interface C. So if you have a class Z that implements the interface C like this, then this class Z will have to override the abstract methods in F, in E, in D, and any other abstract methods in what? In C, because it is implementing C, this C here, and yet C is also extending interfaces D, E, and F. So it is taking on these other abstract methods. So if you implement C, this C up here, which extends these ones below, then you must override all the what? All the abstract methods in D, E, starting with C, in C, D, E, and F. So that's how interfaces operate and interfaces with classes. That's how. So once you implement the interface, then you can override the what? The methods, the abstract methods. So using an example virtual, let's demonstrate the concept of multiple inheritance. Okay, let's demonstrate this. So let's have one abstract method in each of the interfaces. Let's have public abstract void. Let's have it. Let's have it like that. Boom. That's one abstract method. Then here we have public abstract void run like that. Then down here, so now you can see class is already complaining because you have to implement these abstract methods. So here we have public abstract void it, and here we have public abstract void walk to remember, like that. So by implementing C, and this C extends D, E, and F, we have to override all of the abstract methods in C, D, E, and F. And then we're going to start with, let's start with the one in C, which is it. So public, it's no longer abstract because we are going to override it. Public what? Void it. Public void it. Like that. And that's one down. Then we override the second one in interface D, that is public void hit and run, it is run, then give it a body like that. Then the one in E was what? It. So override public void it, give it a body, and the moment you override the last one, then this error should go away. Like override public void walk, like that. Give it a body, and the error disappears. So this is how you can demonstrate what? The concept of multiple inheritance in interfaces, like that. It's kind of too much, so you can maybe not write so many interfaces that you have to override in the paper. But you don't have to give any. Okay, you might maybe, but you don't have, because you're returning nothing, and they're not asking you for any output here. So you just doing this is fine, because this will compile. It won't run. It won't output anything on the console, which they don't want you to do, but it will run, which is what they want. So by doing this, we have shown multiple inheritance using what? Interfaces. This is inheritance here. Multiple inheritance using interfaces, and these are interfaces. And you're using multiple inheritance on a what? An interface. That's what they wanted. Okay. So part C is using an example of your choice. Define an interface that contains one static method. Remember the static methods we did. Did we do them? Oh yeah, this one. So they want something like this. Let's do this, because this will cause an error when we start running code. We want a static method defined like that. So using an example of your choice, define an interface that contains one static method and one abstract method. Implement this interface. Okay, let's first do this using an example of your choice. Which interface should we go for? Let's call it example. This is not a class, it's an interface, public interface. Interface. So they want one static method. So we say public static, let it return nothing. Let us call it run. Let's use simple ones. Give it a body and say this runs like that. That's our static method. And one abstract method. So let's put the abstract method up here. Say public abstract void hit. That is an abstract method, so it's an incomplete method. It has no body. You end there. Implement this interface using two different classes, which must call these methods in their main. So we are going to use two different classes. I'm going to put them down here. Class number one is going to be, let's call it class number one. Class one. This class number one, implement this interface using two different classes. Okay, this class number one and the other class number two must implement the what? The interface. And then we must call the methods that class implements in their what? In their main methods. So class number one implements the interface what? Example like this. What did we say about implementing interfaces that have abstract methods in them? It means you must what? Override this abstract method and give it a what? An implementation of your choice. So this is public void, so no longer abstract, hit, like that. And our implementation is I've been hit. I've been hit. Okay. So the trick here is you must understand that these static methods in interfaces cannot be overridden because you cannot override static what? Static methods. But you can still access this static method after implementing the what? The interface here. So by implementing this interface on this class, we have access to this method here. But we cannot override it because we cannot override static methods. That's the trick there. So this class must have a main method. So let's give it one. And then they want us to call these methods here, these methods in the interface inside the what? Inside this class. But remember earlier when we were doing this number here, we cannot instantiate interfaces. So we're not going to create objects of type interface example. We're going to create objects of that, of what? Of this type of class 1. So class 1, create an object. This is going to be new class 1, like that. And this object is going to call the methods on what? On this interface. So the first method there is what? Is hit, like that. But if you have been following the videos, there's in one of the videos I explained one of the videos that had to do with two-dimensional arrays. So I explained that you cannot call a static method using a what? Using an object. So if we say object and try to call this static method here called run like this, it won't compile because you cannot use objects to call static what? Static methods. So how do you call static methods without using objects? You have to use the class that has that what? That has that static method. And since, remember, interfaces are classes because they are abstract classes like this. Abstract class. That's an interface. So an interface, since it's also a class internally, it's a class, it's treated as a class internally in Java. So all we have to do is get this class name here. Example, get the class name, dot, and then you can have access to the what? To the method run. So this method run resides within this interface here. That's why we need to use the interface name like this, and then use this dot accessor, and then we can access the what? The static method, but this is only for what? For static methods, not for these other methods. Like we cannot say example dot hit. That won't compile as well, because this will require an object, just like we've done up here. So we have what? We have called the methods hit and the method called the method hit and the method run for this class 1. So let's do class 2 down here. So class called class 2, which also implements example, the example interface, is going to have an overridden method. Yeah, overriding the abstract one, the public void. I think it's called run. Hit or run? Hit. Yeah, it's called hit. So this is going to say hit and run. Then our class 2 will also have a main. Remember, we cannot override the what? Static methods. So that one you leave. You cannot override the static method, so you leave it. So you we are going to have our main method in class 2, PSVM, and our main method is going to be create an object of type class 2. This is a class 2 object, and this object will have access to the heat method, but it won't have access to the static method. And to have access to that method, we must use the example name, the interface name example, and then we can have access to the run method on it, like that. So the question says, define an interface that contains one static method, this static method up here, and contains one abstract method. This is the abstract method. And then we must implement this interface using two different classes. These are our two different classes. class 1 and class 2. And these two different classes must call these methods in the interface in their main, which we have done here. This is how you call methods using this dot accessor, and then you write the method call like this. So you are calling the methods down here in the main methods of these classes. So capturing input at runtime is not required, so we are not required to use the scanner. So every time you say capturing input, just know you must consider using a scanner. But this time they are saying we don't need to capture input, so we don't need to use the scanner. But output on the screen through the implemented methods is a must. So you must implement the methods and make it so that you can output something on the screen. So we are going to use this output stream here, this one to output what stuff on the console. So we are going to do it for the overridden method here and output it and run, and then use it for the overridden method here and output have been hit, and then for our static method it says what this runs. Okay, let's say this is static. Okay, yeah, that will make more sense. So what next? Oh, next is you must show your output. So the output that you will get, let's get rid of this. The output you will get, you must run this not at the same time. So let's first run the class 1 implementation, and we should get have been hit, and this is static. So we are getting, let's move this to the right. We are getting have been hit because that is what is called first. This is what is being executed first, and this runs this piece of code here. This one. So you're seeing I've been hit. And then the next piece of code that runs is what? Example.run. And this runs this static method here, which says this is static. So that's class 1. Then class 2 does something similar. It first runs the hit method, and then it runs the static method like this. So the hit method in our class 2 runs this piece of code which says hit and run, and then the static one which says this is static. So you must show this output in the paper. Usually you just have to go down after writing all that code, then you say output is, then you just write the output here. So the first one is what was the first output for this? It is have been hit. Write like this. Then the other one is this is static. Then the other output is hit and run, and the other output is this is static, like that. So that will be your output. And that is the end of the question. Oh yeah, that's the end of the question. Okay, so let's do number 4 and some